As an important component of modern electronics, transistors that were invented in the late 1940s have revolutionized our digital world. These small but versatile components have three terminals, that is, the collector, the base, and the emitter. They are made from semiconductor materials such as silicon or germanium and are capable of amplifying and switching electrical signals, making them essential components in the wide range of electronics such as computers, smartphones, and others. In today's video, we are going to use transistors as a switch to help in detecting the level of water in the water reservoir. In our water level system, we are going to use the following components: 2 NPN transistors, 2 330 ohm resistors, 2 LEDs, a breadboard, jumper wires, batteries with a battery holder, crocodile wires, multimeter, a bottle to act as our water reservoir and the source of water. Now let's begin by fixing our breadboard. So we are going to put 2 transistors on the breadboard. We now need to connect the resistors on the collector terminal of the breadboard. But we need to identify which one is the collector terminal. So we are going to use the multimeter to identify the collector and the emitter terminals of the 2 transistors. To identify the emitter and the collector terminals of the transistor, we attach the red wire of the multimeter on the base, which is the middle terminal of the transistor, and the common one on the either terminals of the transistor, while noting the values. The terminal that gives a bigger value will be our emitter, while the one that gives a lower value will be our collector. So this terminal here, it gives a value which is 606. Then this one gives a value which is 599. So it means this terminal which gives a bigger value is my emitter, and then this one is my collector. Next, we connect a resistor on the collector terminal of the transistor. So we do the same thing for the second transistor. Identify the collector and the emitter terminals. So this first one, this terminal is my collector because it gives a smaller value. Then I connect the resistor on the collector terminal of the transistor. The LED has 2 terminals. One terminal is longer than the other. So the longer terminal is positive and the short one is negative. So this is positive terminal, this is a negative terminal. The negative terminal is one that we connect on the resistor. I'm going to do the same thing for the second transistor. The negative terminal of the LED is connected on the resistor. As you can see on our circuit diagram, the positive leg of the LED is connected on the positive terminal of the batteries. So I'm going to use the jumper wire to connect this positive terminal of the LED on the positive lane of our breadboard for that first LED, and also I do the same thing for the second LED. So from the positive terminal of the LED to the positive lane of the breadboard. Now we are going to connect the emitter terminal of the transistor onto the negative terminal of our batteries. So we are going to use a jumper wire to connect to the negative lane of the breadboard. So So we are going to do the same for the second transistor from the emitter terminal to the negative lane of the breadboard. Following our circuit, we have a wire that is connected on our base. So we are going to use the jumper wire to connect on the base terminal of our transistor. So we also do the same thing for the second transistor. Connect on the base terminal of the transistor. So these wires, as you can see, are on our circuit board. They are just hanging. Then, so we also have a hanging wire that is moving on the positive terminal of the LED. So we are going to connect that wire in the positive terminal of the LED. It also remains hanging. So we do the same thing for this second LED. So from the positive terminal of the LED, now what you're going to do next is powering our breadboard. So to power our breadboard, so you're going to fix the batteries inside our battery holder. So the battery holder has two terminals. It has a red wire and a black wire. Red wire is positive, a black wire is negative. So for convenience, I'm going to put a jumper wire in the positive lane and then another jumper wire in the negative lane of the breadboard. Then I'm going to use two crocodile wires. So I'm going to use the crocodile wire to connect from the positive terminal of the battery to the wire, the jumper wire that is coming from the positive lane of the breadboard. So I use another crocodile wire to connect from the negative terminal of the batteries to the jumper wire that is coming from the negative lane of the breadboard. These hanging wires, they are going to act as our sensing points for the two LEDs. So to make it easy for us to connect these wires inside our water reservoir, so we are going to use crocodile wires. So I'm going to attach crocodile wire here. So I do the same thing for the second LED. So the two hanging wires, I attach crocodile wires. So next, we are going to attach these two hanging wires for each LED inside our water reservoir. Wires from the white LED will be indicating the low level of water in the water reservoir, while wires from the green LED will be indicating the high level of water in our water reservoir. So the two hanging wires from the white LED, they are going to be attached on the low level. I'm going to use salt tape to attach them on the opposite sides, but they should be at the same level where we have indicated low level of water. So that is the first wire. Now I'm going to attach the second one. So I'm now going to attach these two wires from the green LED onto the high level. So while connecting, ensure that the wires, they are not touching each other. So that's why I'm putting them on the opposite sides. So we are done attaching the wires inside our water reservoir. So the next thing that we are going to do, we are going to pour water. So when water reaches the low level, the white LED will go on, and when it reaches the high level, the green LED will go on. Now let's carefully pour water inside our water reservoir as we are observing the LEDs. So our water has reached the low level. Let's continue pouring water as we are observing the brightness of the green LED. So when our water reaches the high level, now we are going to remove water from our water reservoir such that we are able to observe the LEDs going off. So we are going to remove this. As water goes below the high level, the green LED should go off. Yeah, as we can see, the green LED has gone off. So similarly, when water goes below the low level, the white LED should also go off. So you can see the water has reached below the low level, and the white LED is also off. So the transistor has three terminals: the base, the collector, and the emitter. When a small current flows through the base, it allows a larger current to flow between the collector and the emitter. The two hanging wires connected at the base and the positive terminal of the LED act as sensing points, such that when the water level rises and gets into contact with them, it completes the circuit by bridging the gap between the two hanging wires. This allows current to flow through the base of the transistor and therefore turning on the LED, which indicates the presence of water at the detected level. Water in this case provides the conductive path between the base and the ground of the transistors. Thank you for joining us today. In today's video, we have learned how to use transistors as a switch to indicate the level of water in the water reservoir. Let me leave you with this simple exercise. In your spare time, design a 3-level water system. By 3-level, I mean your system should be having 3 LEDs that indicate low, middle, and high. And please share your progress and challenges with us in the comment section below. Don't forget to like and subscribe to our channel for more educational videos. See you in the next one. Bye-bye.